Have you ever struggled with unit conversions in your Swift app? Hi, my name's Stuart Lynch, and in this video, I'll show you how to harness Swift's powerful measurement API to convert, format, and even create your own custom units. With practical examples, you can follow along. If you've ever needed to convert between miles and kilometers, Celsius and Fahrenheit, or pounds and kilograms in your Swift app, you're in the right place. Swift's measurement API makes working with units and performing conversions not only easy, but incredibly powerful. But what you might not know is just how extensive this system is. Swift includes dozens of measurement types covering everything from distance and speed to magnetic flux, electric capacitance, and even fuel efficiency. Whether you're building a fitness tracker, a cooking app, or a scientific calculator, there's likely a unit built right in for you. In this playground, we'll focus on some of the most common and practical measurement types, like length and mass and temperature, volume, and more. And you'll learn how to create and convert measurements, perform arithmetic operations, format them for localization, and even define your own custom units. And don't worry, we'll also explore how you can discover the full list of available units, so you're never limited to what we cover here. So let's dive in and unlock the full potential of Swift's measurement API. There is a starter playground for this video, and you can download it from the link in the description. If you work along with me, you are more likely to retain what you'll learn, and in the end, you'll have a completed playground that you can refer back to in the future. And there's also a complete playground branch that has the completed project. Just make sure that you download the zipped archive for the starter playground and project if you're working along with me. Swift's measurement API is designed to help you work safely and intuitively with values that represent physical quantities, like distance, weight, or temperature, by associating them with a specific unit. So on this page, we'll cover the fundamentals. I live in Canada, and for the most part, we're metric. For example, we measure distance in kilometers, and we even spell kilometers differently from the US. If you're coming from the US and someone tells you that the store is 5K away, meaning 5 kilometers or 5 clicks, how far is that in miles? Well, we can use the measurement API to do that work for us. So we can let distance be equal to a measurement object where the value is 5, and we can specify a unit, and that unit is a unit length dimension type. And we can press period then and see that we have a number of different options for this. And this 5 is in kilometers. So we can do the conversion by letting the distance in miles be equal to the distance converted to, and we don't have to specify the base unit length because the conversion can only be done within the unit length class option, and one of those is miles. So we can print out that distance using string interpolation to do the conversion for us. And when we do that, not only do we get the conversion, but we also get the abbreviated unit. And I'll show you how you can control that later. All conversions are done that way. So you can create measurement objects by specifying a value, which is a double, and the particular unit class and that unit type for that value. So if you want to convert the mass, which is your weight, which might be, say, 215 pounds, because we still say pounds mostly in Canada, to kilograms, how can we do that? Well, we'll let weight be equal to the measurement, where the value is 215, and the unit, it's a unit mass type, and we can specify pounds. And then we can let our weight in kilograms be a new property, and that can be calculated by being equal to the weight using the converted method to the kilograms type. And we can then again use string interpolation to print out our weight, which is the weight in kilograms. If you go almost anywhere outside the US, the temperature is measured in Celsius. So if you're told that it's 24 degrees Celsius outside, what does that translate to in Fahrenheit, which is used in the United States? So again, we'll let a variable be called temperature, which is a measurement type, where the value is 24, and the unit type this time is a unit temperature, and the type would be Celsius. So our temperature in Fahrenheit is going to be equal to the temperature converted to Fahrenheit. Once more then, we'll print out the temperature and then use string interpolation to print out the temperature in Fahrenheit. Well, the same goes for speed. Our speed limits in Canada are in kilometers per hour. So if you see a sign when you come up to Canada that says the speed limit is 50K, as we say, what does your American odometer's reading say? So we'll let the speed limit be, again, are you getting the picture now? It's a measurement type where you specify the value, which is 50. Then you have to specify the unit, which is a unit speed. And the type that we're getting, that 50 in, is a kilometers per hour. And then we can let the speed limit in miles per hour, a new variable b, equal to that speed limit converted to miles per hour. We can print out our speed limit then using string interpolation and then print out the speed limit in miles per hour. So this is all pretty common, but I just want to give you one more example here that you might not be aware of. Another common and useful conversion is volume. So if you're coming to Canada from the United States and you're filling your tank at the pump and it says that you filled it up with 56 liters, well, how many gallons is that? So we'll let the gas be the measurement for the value of 56, and the unit is unit volume, and that's in liters. That's how we issue it here in Canada. So to do the conversion, we'll let the gas in gallons be equal to the gas converted to gallons. And you can then print that out to get the gas in gallons, which is about 14.8 gallons. Now, if I found an old gas pump in Canada that was still pumping out gallons, and I put in 14.8 gallons of gas, how many liters would that give me? And it may surprise you that it would not be the same as the 56 liters that we just saw through our conversion. Why? Because US gallons are not the same as Canadian gallons. Canada uses the imperial gallon, while the US uses the US customary gallon, and they are quite different in volume. So we can let the gas be equal to the measurement, where the value is 14.8, which is the number of gallons I'm going to fill my tank with in Canada, but the unit is a unit volume, but we have to specify imperial gallons. And then if we want to find out what that gas in liters is, which is what we use now, we can do that gas converted to liters. And when we print that out, we see that the volume is different than it was before. Now we've just covered a few of the measurement dimensions. If you open the Apple documentation and navigate to Foundation Units and Measurement, and you can either do that in Xcode or you can just use this link here, right here on the page. And when that page opens, it'll show you all of the different dimensions that you can use. And if you drill down on any one of these, you can see each specific predefined unit types that can be used for your conversions. So using measurement in Swift is safer and more expressive than working with raw double values for several important reasons. You're less likely to accidentally mix units as the compiler enforces unit compatibility, and the measurement API improves code readability and helps avoid incorrect assumptions about units. I hope you're enjoying this video, and if you are, please give it a thumbs up and leave me a comment. It would also really help if you could subscribe to my channel and enable notifications so that you're alerted when I drop a new one here on YouTube. I put out weekly videos and I seldom miss a week, so if you really want to support my work, you can buy me a coffee. A link is in the description. Now that was a bit repetitive, so let's get into something more interesting, which is arithmetic operations. Once you've created measurement values, the next step is using them in calculations. Unfortunately, Swift makes it easy and safe to perform arithmetic operations with measurements, thanks to operator overloading and automatic unit conversions. Behind the scene, Swift ensures all units are compatible before performing the calculations, helping you avoid mistakes that often happen when working with raw numbers and doing your own conversions. So let's take a look at addition. So long as the unit measurement class is the same, you can add units of different types together. For example, if I measure a room that is measured by 5 meters in length, but for the width, the measurement is in centimeters, like if it was only 325 centimeters. So we can add the two sides together simply by setting total length be equal to the room length plus the room width. And then to print it out, we can print that total length, and again using string interpolation, and we discover that it converts that room width, which was centimeters, into meters and adds it to the room length to get a total length of 8.25 meters. This is also the case for subtraction. Your weight is measured in kilograms here in Canada, which is metric, and you might come in at 70 kilograms. But then you're told that you've lost 5 pounds, so how much do you weigh now? So our weight loss is going to be a measurement with a value of 5, and the unit being a unit mass of pounds. So to calculate our current weight, that will be our initial weight minus the weight loss. And then when we print this out, we'll see that it's converted those pounds into a fractional kilograms, and our current weight is close to 68 kilograms, 67.73204 to be exact. Now, when you multiply, you can multiply any unit of measurement by a double. So for example, I could define 1 hour like this, where the value is 1 and the unit duration is in hours. 3 hours then would be 1 hour times 3. And although this looks like we're multiplying by an int, the 3 is actually converted automatically to a double by the compiler. Now, however, if we specify a variable called factor, which is equal to 3, which would then define factor as a int through type inference, we'll get an error if we change that 3 to factor. We'd have to double that factor variable to make sure that the calculation works. And division works in exactly the same way. We can measure units of energy in joules or kilojoules. Now, let's say there are 4 different units sharing a load. So we can determine that by division. So the per unit energy would be equal to the total energy divided by 4. And then we can print out the energy per unit using string interpolation. So 250 kilojoules per unit. Creating and converting measurement is great, but at some point you'll need to present those values to your users, and that's where localization and formatting come in. Whether you are in the US, Europe, or Asia, Swift makes it easy to display measurements using units and styles that feel natural to them without writing custom formatting code for every case. We can use a measurement formatter to convert measurements into human-readable strings and adjust the formatting styles and localize them. On the first page, we converted between Celsius and Fahrenheit using the converted method, but you might not be sure what system different countries are using. So here we have an example of a temperature that has been declared as Celsius at 22 degrees. Well, we can create a measurement formatter. And then we can specify the locale for the formatter as a locale, and we can specify an identifier. So for example, we can specify EN_US for the United States. And we can also specify a unit style like long. And then we can print it out using a formatter.string from temperature method. And here we see that it's displayed as 71.6 degrees Fahrenheit, despite the fact that it was defined in Celsius, no conversion was necessary. But what if you are in Germany? Well, the identifier is DE. So let's add that code. And when we print that out, what do we get? It still remains now in Celsius, but we get the German word for degrees. In this example, I have a distance of 5 miles. How can I express this in an understandable way to someone from France? Well, in this case, we'll create another measurement formatter. We'll specify the locale using a locale with an identifier of FR_FR. We'll choose a unit style of, say, medium this time. And then we'll print out the formatter's string from that distance. And we'll see that 5 miles is just over 8K. And no, that's not 8,000 K. In France, the decimal point is a comma, not a period. Well, here we have height that's provided as 1.8 meters. Well, I can copy the formatter and locale from above, but I'm going to change the identifier to en_US. And this time for the formatter, I'm going to specify unit options. And for those unit options, though, I'm going to choose provided unit. And once again, I'll print out the formatter string from the height. But this time, it's going to keep the printout in the same unit of metric, despite the fact that the locale is in the imperial US. In this next example, I'm just going to copy the code from the previous example. And then instead, I'm going to change the unit option to natural scale. And I'm going to run it once more. And you can see that it gets converted to a more convenient unit when possible, which in this case is just under 71 inches. Now, what if you wanted to round this off to just one decimal place? So I'm going to copy from the previous example. But before the print statement, I'm going to create another formatter as an instance this time of a number formatter. And then with a number formatter, I can specify the maximum fraction digits. And I'll specify 1. And then I can update the measurement formatter to specify that this measurement formatter's number formatter is our newly defined one. And then when I print this out, we get that rounded value. Well, you can also use the new format style that was introduced too. And I have a couple of videos on both number formatter and format styles, and I'll leave links to those videos in the description if you want to dive into those a little bit more. So let's take a look at a couple of examples. I could use an abbreviated unit style. If we have a distance of 5 kilometers to find, I can create a formatted distance using the distance formatted using a measurement style. And here we can specify a width, and that width can be an abbreviated, narrow, or wide width. So let's specify abbreviated. And then when we print that out, we see that it specifies it just as 5 km for 5 kilometers. Now, you may have noticed previously that there was another option called usage when I was using the formatted measurement. So for this weight then, let's create a formatted weight. And that's going to be the weight using the formatted measurement style. And we'll choose both width and usage. For the width this time, I'll choose narrow. And for the usage, I have a number of different options, and you can read what each one is, but I'm going to choose person weight. And I'm going to print that out. And I see that it's 70 kilograms. And now for this last example on speed of 88.888 kilometers per hour, I want to quickly have it display the full wording of kilometers per hour, but round it off to one decimal place. And this is easy because we can use a formatted measurement style for formatted speed. So formatted speed is equal to the speed formatted, and specify here for the measurement a width, but also this time a number format style. For the width, we'll specify wide to get the full text. And that number format style can be a dot number, and that number can have a precision, and that precision can be a fractional length of 1, all done in a single line of code. So I can then print out the formatted speed for that formatted speed, and it's 88.9 kilometers per hour. Well, Swiss Measurement API comes packed with dozens of built-in unit types, from meters and liters to volts and calories. But what if your app needs to represent a unit that isn't included? And this is where custom units and dimensions come in. Well, you can extend existing dimensions like unit length with your own custom unit. And you can also define brand new dimension types where no existing category fits. For example, for currency or steps or scores. And you can use custom symbols and conversion logic for accurate and expressive representations. And this will be especially useful in domain-specific apps like fitness trackers or educational tools or scientific calculators or even games where working with unique units is essential. Now, it's important to understand that each dimension subclass has a predefined base unit. So we can click on this link here, and that's going to open the Apple documentation and go directly to unit length. And we can see right here that its base class is in meters. That's the default. So if we want to create an extension on unit length, it has to be done outside of the code block closure here on its own. Extensions have to be on their own. So we can create our own dimension that I'm going to call football field. And it's going to have a static property that we're going to define. And it's going to be our own unit length type. And we're going to specify the symbol and a converter. So for the symbol for our football field, I'm just going to use FF. And that's going to represent one football field. Now the converter, though, since we're dealing with length, we need a unit converter linear type. And we'll need to specify a coefficient that's a double representing one football field. Now in the US, we know that it's 100 yards. But since our base type is in meters, I had to convert that. And I did that offline using a measurement converter and found that it is 91.44 meters. So that's going to be our base unit here for this football field. Now let's say we want to know the length of 3 football fields. Well, we can define that as the distance using a measurement where the value is 3 and it's a unit length. But now we see that we've actually now got a football field that we can use. And then we can let that distance in yards be, to do another conversion, to take that distance and convert it to another unit length type of yards. And we print that out. We find that it's 300 yards. 3 football fields is 300 yards. Now, in this next example, I want to know how many football fields would fit into 500 meters. Well, now that we have our football field extension on unit length, I can do that conversion and print it out. So let the distance in football fields be equal to the distance converted to football fields. And I can print that out. Great. 500 meters is almost 5.5 football fields. And in this final example, I want to explore how we can create our own custom dimension. Now, you may have noticed that there is no currency measurement dimension like we have for mass, length, and temperature. Well, what we can do is we can create our own dimension. So first, we need to create a final class, and we'll call it unit currency as a dimension type. But since we're subclassing a dimension that is itself unchecked sendable, we must also restate that for this subclass. Next, then, we can define our static units that will represent each one of our different currencies. So we're going to start with USD to represent US dollars. And that then is going to be our unit currency dimension with a symbol, and we'll use capital USD. And then for the converter, we're going to use a unit converter linear where the coefficient is 1. So we're going to assume then that our US dollars is going to be our base class for this dimension. So let's create another static property to represent each one of the currencies that our app wants to support. And I'm just going to do 2 here for simplicity. For example, the euro, which has a symbol of EUR. And then for the converter, we'll specify the conversion rate, which at the time of this video creation was 1.136. And I'm going to do one more for Canadian, and that's using the CAD as our symbol. And the conversion rate coefficient was 0.729. So I said that we assumed that our base rate is going to be the US. Well, we have to specify that. And we do that by creating an override for the base unit function. And it's going to return a unit currency type that will be US dollars. And it looks like we actually can't use self here. We have to actually specify unit currency. So let's say then that we want to use this then, and I'm traveling to Europe and I purchase something in euros for $150. So the price is a measurement with the value is 150, and the unit is a unit currency of euros. So what's the price in US dollars and in Canadian dollars? So we can do both of those conversions. And we can print both of those out. So as you've seen, the Swift Measurement API offers a powerful, flexible, and type-safe way to work with real-world quantities, whether you're converting between miles and kilometers, formatting temperatures for different locales, or defining your own custom units and dimensions. By using measurement instead of raw numbers, your code becomes more expressive, less error-prone, and better suited for internationalization. Now that you've seen how to create, convert, format, and extend measurements, you're equipped to bring a new level of precision and professionalism to your Swift apps. If you found this tutorial helpful, please give it a thumbs up and leave me a comment. You can subscribe to my channel to get notifications of new videos. And remember that you can also download my YouTube channel listing app for free and quick access to all of my 350 plus YouTube videos. A link's in the description. And also remember I have a full SwiftUI course available on my Teachable site where you learn how to build a fun, multi-targeted app.